Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the no-work process. Let's talk about the background of the no-work process. The heat transfer and work of most thermal engineering equipment are completed separately. All kinds of heat exchangers only complete the heat transfer and do no work at the same time, no work process. When various power machines complete the work process, there is basically no heat exchange with the surrounding, and the working fluid undergoes an adiabatic process. The characteristics of heat transfer with no work and difficult heat transfer during work doing bring great convenience to the thermodynamic analysis and energy calculation. There are two processes of no work, that is, process with no expansion work and process with no technical work. Firstly, let's talk about the process with no expansion work. This means that the closed system does not do expansion work for surrounding or consume external work when its state changes. If there is no friction, the process of low expansion work is also a constant volume process, since we have this relation. If there is friction, the low expansion work process must be a process of increasing specific volume, since we have this relation. For example, process of gas expanding freely to vacuum is a process of low expansion work. According to the first law, when a system performs a process with low expansion work, the heat exchanged with the surrounding must be equal to the change in internal energy. Integrating the above equation, we have this relation. This is applicable to any working fluid, no matter whether there is friction or whether it is internal equilibrium, as long as there is no expansion work done. This equation is correct. For ideal gas, we have this relation. When the specific heat of ideal gas is constant, this relation becomes. The process with no expansion work is not the same process as that of constant volume. They are consistent only when there is no friction. The process with no expansion work only changes the specific volume without friction, and the constant volume process consumes no external work only when there is no friction. In the process with no expansion work, whether or not there is friction, the heat must be equal to the change in internal energy, while in the constant volume process, only when there is no friction, the heat is equal to the change in internal energy. Secondly, let's talk about the process with no technical work. Taking a thermal system of steady flow process as example. This means doing no technical work for surrounding or consuming no external work in a process. If there is no friction, the process with no technical work is also a constant pressure process, since we have 0 dP. If there is friction, the process with no technical work must cause a pressure drop, since we have negative dP. For example, the fluid flew in various heat exchangers and transportation pipelines is such a process. According to the first law, when the thermodynamic system performs a process with no technical work, the heat exchanged with the surrounding must be equal to the change in enthalpy. Integrating the above equation, we have this relation. Again, this is applicable to any working fluid, no matter whether there is friction or whether it is internal equilibrium. As long as there is no technical work done, this equation is correct. For ideal gas, this relation becomes: when the specific heat is constant, this relation becomes: the process with no technical work is also different from the process of constant pressure. They are constant only when there is no friction, and the process with no technical work only changes the pressure when there is no friction, and the constant pressure process consumes no technical work only when there is no friction. In a process with no technical work, whether or not there is friction, the heat must be equal to the change in enthalpy, while in the constant pressure process, the heat is equal to the change in enthalpy only when there is no friction. It should be emphasized that in various heat exchangers, although there are large or small frictional resistance, and therefore there are different pressure drops, the heat exchange with the surroundings can be definitely calculated by the change of the enthalpy of fluid. This is because the fluid performs a low work process with no technical work, which should be calculated in this way, rather than a simplified calculation method that approximates the constant pressure process. Okay, that's all for this task. Thank you very much, and see you next time.